Hi guys! I know that you're inquiring about matter, about why matter matters. So let me read a bit for you so you can learn about this matter. Matter by Sally M. Walker. Be a word detective. Can you find these words as you read about matter? Be a detective and try to figure out why they mean. You can turn to the glossary on page 46 for help. Atoms, boiling, cubic units, dense, evaporates, gases, ice, liquids, mass, matter, melts, molecules, solids, states, steam, volume, water vapor. What is matter? Everything around you is made of matter. Matter can be soft or hard. Matter can be any color. It can be even invisible. Matter takes up space. It can be white. Solid objects are made of matter. So are liquids like water and gases like air. Solid, liquid, and gases are the three states of matter. All matter takes up space and can be white. Matter has mass. Mass is the amount of matter an object is made of. A lot of mass is harder to lift than a small amount of mass. Prove it with an empty jug of water. A big book is hard to lift because it has a lot of mass. Air doesn't have much mass. A jug filled with air is easy to lift. The jug looks empty, but it is filled with matter. Can you guess what matter it is? It's air. Air takes up space inside the jug, but the air doesn't have much mass. It's easy to lift the jug. A jug filled with water is much harder to lift than a jug filled with air. Fill the jug with water. The space inside the jug is the same as before, but it is much harder to lift the jug now. That's because the matter inside it has more mass. Water has much more mass than air. Matter is made of tiny particles called atoms. Billions of atoms can fit on the period at the end of this sentence. Atoms can join together to form groups called molecules. Molecules are bigger than atoms, but millions of molecules will still fit on a period. Molecules are always moving. Some molecules have a lot of space around them. They can move freely. Other molecules are packed tightly together. They still move, but not as freely. Prove it with an experiment. Stand in a big room with two friends. Spread your arms like airplane wings. Pretend to fly around the room. You have plenty of space. It's easy to fly without bumping into your friends. Molecules with a lot of space around, they don't bump into each other very often. If kids are pretending to be molecules that have a lot of space around them, they can move without bumping into each other. If you stand very close to your friends, you can move without bumping. Now put your arms at your sides. Stand as close to your friends as you can without touching. You are packed tightly together. You can spread your arms without hitting each other, but you can still move. You can shake or jump up and down. When you all move at once, you may bump into each other. Tightly packed molecules move the same way. Matter takes up space. What do we call the amount of space that an object takes up? Chapter 2. Taking up space. All matter takes up space. The amount of space that an object fills is called volume. To find the volume of an object, you must know its length, width, and height. The volume of a solid is made in cubic units, such as cubic inches or cubic centimeters. A cubic unit includes length, width, and height. Sugar cubes are solid matter. Its sugar cube volume is about 1 cubic centimeter. A solid object's volume always stays the same. You can move the object or break it into pieces, but it still takes up the same amount of space. You can prove this. You will need 27 cubes of sugar. Put the cubes in a line on a table. Each cube is about 1 centimeter long, so the length of the sugar line is 27 centimeters. But this measure doesn't tell you the sugar's volume. You need 2 more measures. Can you guess what they are? To find the volume, you must also know the width and height of the sugar line. The width is 1 centimeter. The height is also 1 centimeter. Now you have all the measurements you need. First, multiply the width of the line by its height. 1 times 1 is 1. Then multiply your answer by the line's height. 1 times 27 is 27. So the volume of the long, narrow line of sugar is 27 cubic centimeters. Next, stack the sugar cubes. Put 3 cubes in each stack. You'll have 9 stacks. Push the stacks together to make a giant sugar cube. The giant cube is 3 centimeters wide, 3 centimeters high, and 3 centimeters long. Does it take up the same amount of space as the long, narrow sugar line? Find the giant cube's volume and see. Multiply the width of the cube by its height. 3 times 3, it's 9. Then multiply your answer by the cube's length. 9 times 3, it's 27. The volume of the giant cube is 27 cubic centimeters. The volume of the giant cube is exactly the same as the volume of the sugar line. The cube just looks smaller because the sugar blocks were moved around. Chalk molecules are arranged in a certain pattern. If you break a piece of chalk, does the pattern change? Chapter 3. Solid matter. The shape and volume of solid matter always stays the same. Chalk is solid matter. Its molecules are arranged in a certain pattern. Chalk can be broken, but the molecules in each piece still have the same pattern. Think about moving molecule experiment you did. When were you more like something solid? Your group was more solid when you stood close together. Stand close to your friends again. Wrap your arms around each other. Now your group is really packed together. Its shape can't change. The molecules in solid matter always stays in the same place. The solid keeps its shape. When the molecules in matter are very close together, scientists say the matter is dense. Molecules in most solids are tightly packed, so solids are dense matter. Water is liquid matter. Does the volume of a liquid always stay the same? Chapter 4. Liquid matter. Liquids are another state of matter. Liquids are usually measured in fluid ounces or millimeters. These units don't have cubic in their names, but are still cubic units because they include length, width, and height. Solid matter stays in hard chunks, but liquid matter flows smoothly. The volume of a solid always stays the same, so does the volume of a liquid. But liquids are very different from solids. Fill a glass with water. Watch how the water comes out of the faucet. Does it fall in hard chunks, like blocks from a box? No, water flows in a stream. A liquid does not have just one shape. Pour the water from your glass into a bowl. See how the molecules quickly spread to fit the bowl's shape. A liquid flows into all parts of a container. It spreads out until its surface is smooth. Liquid matter flows to fill the bottom of any container. You can pour a liquid because its molecules can move freely. They don't cling together as tightly as the molecules in a solid. The liquid's molecules are not as tightly packed. Liquids are less dense than solids. Some liquids are more dense than other liquids. You can prove it. You will need cooking oil, liquid soap, water, food coloring, a glass, and a measuring cup. For this experiment, you will need cooking oil, liquid soap, water, food coloring, a glass, and a measuring cup. When you pour the soap into the glass, it sinks to the bottom. The oil rises to the top. The soap sinks because it is denser than the oil. Pour 1/4 cup of oil into the glass. Now pour in 1/4 cup of liquid soap. What happens to the soap? Why do you think it sinks to the bottom? The molecules in the soap are more tightly packed than the molecules in the oil. Because the soap is more dense, it is heavier. It sinks beneath the oil. Get 1/4 cup of water. Add 1 drop of food coloring to it. Slowly add the colored water to the oil and soap in the glass. What happens? Is the water more dense than the oil? Is the water more dense than the soup? The water sinks below the oil, but the water flows above the soap. Air is a gas. Gases can't be seen. How can you tell when air is moving? Chapter 5. Matter as a gas. Gases are the third state of matter. The molecules in gases are far apart. They are so far apart that we can't see them. But we know they are there. We can't see air, but we can see leaves blow in the wind. Wind is moving air. Gases are invisible, but they still take up space, just like solids and liquids. You can prove this with a drinking straw and a tiny piece of paper. A straw looks empty, but it is filled with air. Breathe in a little bit to keep the tiny piece of paper from falling out the straw. Hold your breath until you're ready to blow through the straw. Look at the straw. Is it filled with anything? Yes, it's filled with air. Put one end of the straw in your mouth, look at the ceiling, balance the tiny paper on the other side of the straw. Now blow through the straw. What happens to the paper? It blows off. Why does it happen? The air leaving your mouth needs space. It pushes the air that is already in the straw. Straw air pushes against the paper. It pushes the paper away. Like liquids, gases can't change shape. The molecules in gases move around even more freely than the molecules in liquids. If you blow air into a glass, the air does not stay at the bottom. Instead, air molecules flow freely up and out of the glass. To keep a gas in a container, you must completely enclose it. Blow air into a balloon. If you don't hold the balloon closed, the air rushes out. But if you tie the balloon, the gas is enclosed. The balloon stays full. A gas spreads out to fill whatever container it is in. The air from your small balloon will spread out to fill the whole room. When ice melts, it changes from the solid state to the liquid state. What makes molecules change from one state to another? Chapter 6. Matter can change state. Matter can change from one state to another. Adding heat to matter makes molecules move faster. Taking away heat makes them move slower. When molecules move faster or slower, they can change state. You know water in all three states. Solid water is called ice. When ice melts, it turns into a liquid water. When liquid water evaporates, it changes into a gas. You can make water change its state. You will need a pot holder, a small pan, stove or hot plate, and a few ice cubes. Wear safety glasses and ask an adult to help you. Dump the ice cubes into the pan. Put the pan on the stove or hot plate. Turn the burner on. What happens to the ice cubes as they are heated? They melt. The solid ice changes into liquid water. As the water heats, can you see bubbles? What do you think is inside the bubbles? Water vapor is inside them. Water vapor is water in the gas state. How do the bubbles move as the water gets hotter? They rise to the top. Soon, the water surface will be bubbling fast. This is called boiling. The gas bubbles pop and escape from the pan. They form a cloud of steam. Steam is hot water vapor. You have made matter change its state. Your solid ice cubes change into liquid water. Then the liquid changes it into a gas. Our world is made of matter. Everything around you is a solid, a liquid, or a gas. Your lunch is made of matter. What kind of matter did you eat today? Even you are made of matter. Can you name any of the solid, liquids, and gases in your body? It's a question that really matters.